My name is Lisa Olivares. I am a volunteer with the Straub Environmental Learning Center and coordinating the Climate Masters program that Bill is doing this presentation joint with. So welcome. We do have another series. I guess I'll go ahead and do a shameless plug for those of you that weren't in here before. The Straub Environmental Learning Center is a great organization that does sponsor a number of environmental education programs for all ages. Included in our adult series is our lecture series that Alex over here, who's the manager of the center, is holding up some flyers that you are all welcome to take. Our first lecture is going to be Thursday, October 28th, and it features Nan Woodman, who's an author, an illustrator, and has done work with National Geographic. And she will be presenting a presentation that for some work she's done with what they call critter cams. So they actually attached cameras to whales and did some different filming, and it's really fascinating and some really great visuals. So if that interests anyone, among the other presentations, I encourage you to pick one of those up. But tonight's presentation, we do have Bill Bradbury here. We're very grateful. He's here to do his climate change presentation. He's the former Secretary of State and was trained by Al Gore to do these presentations. He's given over 200 of them since he has been trained. And most recently, he was appointed by the governor to the Northwest Power Planning Commission, which, among other issues, deals with renewable resources and how it relates to salmon along the Columbia River and in the Northwest. So he'll talk a little bit more about that. And without further ado, Mr. Bradbury, and then we will have some time after for question and answer. So thank you all for being here.
Thank you very much. It's great fun to be here. As was said, I've given a lot of these presentations, and I took a little break from giving a lot of presentations when I was busy running for governor, but I'm glad to be back giving presentations. It's something I really love to do. I do want to say that day before yesterday, 10/10/2010, was a fairly significant climate day. There were 7,347 events in 188 countries with people all working or demonstrating that they wanted climate action. They wanted the governments around the world to deal with what we need to do for climate change. And they did things like community gardens, and other people installed solar panels. Other people planted trees. There were actions, like I said, 7,300 of them all over the world focused on climate change. So really great to see the whole world community being engaged on the issue. As was said, I traveled to Nashville, Tennessee about 5 years ago and was trained by Al Gore. He's trained about 1,200 people in the United States to give climate presentations, and I was among the first 50 to be trained. And we spent our time in Al Gore's family farm barn in Carthage, Tennessee, and he went through the climate show with a scientist standing next to him, and this was the group of the first 50 that got trained. And after that, he started doing trainings in hotels with 200 people at a time instead of 50 at a time. So it changed, but it was a pretty remarkable experience. And I had the opportunity to go with Mr. Gore to train the first 300 volunteers in China. 150 of them were selected by the Chinese government to be trained in giving climate presentations, and the other 150 were selected by non-governmental organizations in China. Spent about 3 days training that group. Had some wonderful experiences, wonderful connections, and of course wonderful food in Beijing. But it's really exciting to see this effort all over the world. He's done trainings in China, he did them in India, in Africa, in Latin America, in the United States, and in Canada. So he's really working very hard to get information around the world. So why has Bill Bradbury done 200 of these? And I think there's one very simple answer. And this is my new grandson, who's now 9 months old. And that's really what keeps me going, is because he's going to have to live on this planet for a lot longer than I will. That's my daughter, Abby, and that's Pippin. She does salad greens, and her sister, my other younger daughter, does horse farming on the South Coast, and she raises vegetables for a whole lot of people. She does community-supported agriculture on the South Coast, and I'm happy to report that she is now pregnant and will have her first baby about a year after my grandson was born. So I have lots of reasons to be concerned about climate, because it's something we want to make sure they can continue to live comfortably here and pursue their chosen profession, which is obviously very dependent on the climate relating to farming. So how many people here were born after 1968? Okay, so there's some. For all of you, photographs of the Earth from space are really very commonplace because you grew up with them. But I was 19 when this picture was taken. It was the first picture most of us ever saw of the Earth from space. And it was a photo taken on Christmas Eve in 1968. It was taken by the Apollo 8 space mission, which was the first U.S. space mission to leave the confines of near-Earth orbit and go around the moon scouting for landing sites. That's the moon right in the foreground. And rookie astronaut Bill Anders was looking down at the surface of the moon trying to find a place to land. They weren't going to land. They were just trying to figure out a place that the next spacecraft could land. And he then looked up and he saw this incredible Earthrise picture. And he snapped it. And frankly, this image really exploded into the consciousness of humankind. And really, when you think about it, taken in 1968, first seen in late 1968, really the modern environmental movement was really born in very close proximity to this picture being seen. Clean Air Act, Clean Water Act, National Environmental Policy Act, and the first Earth Day all came about within a year or two of this picture being seen by people here on planet Earth. Now, this is a picture that was taken 4 years later by Apollo 17 in December of 1972. And what's interesting about this picture is this is the only time during the 4-year series of Apollo missions when the sun was lined up almost directly behind the moon while the spacecraft was making its journey. So the Earth, instead of being partly shrouded in darkness, in fact is fully illuminated. For this reason, this image has become the most commonly published photograph in all of history. No other image even comes close. In fact, 99 times out of 100, when you see a picture of the Earth, this is the picture that you are, in fact, seeing. So it's a very popular photograph. Now, this is an amazing picture that was taken a couple years later, taken by the Galileo satellite in 1990, and it shows a complete day of the Earth turning. So it was taken by the satellite, and it shows a complete day of the Earth turning. Now, coming a little closer to home, this is our atmosphere. And many people today still assume, quite mistakenly, but they still assume that the Earth is so big that we humans cannot possibly have any major impact on the way our planet's ecological systems operate. Now you're looking at the most vulnerable part of the Earth's ecological system, and that's the atmosphere. And it's real clear from that picture why it's so vulnerable. It's vulnerable because it's so thin. Carl Sagan used to explain that if you had an orange covered with a coat of varnish, an orange covered with a coat of varnish, the thickness of the varnish on the orange would be about the same as the thickness of the Earth's atmosphere compared to the Earth itself. So the atmosphere is a pretty thin membrane for us. So let's talk for a minute about the interaction between the sun, the Earth, and the atmosphere. I think all of us know that solar radiation comes from the sun, and it passes through, the light waves from the sun pass through the atmosphere, and most of the radiation is absorbed by the Earth, and in fact that radiation warms the Earth, and some of the radiation is radiated back into space in the form of infrared waves, and some of the outgoing infrared waves are trapped by the Earth's atmosphere, and it warms the Earth further. And this is not a bad thing. This is a good thing, as it's been happened in the past, because we really have this incredible habitable planet. So just look at the Earth in relation to other planets in the solar system. Basically, you have an atmosphere on the Earth, and you have a much thicker atmosphere on Venus with a whole lot more carbon dioxide and other gases in it. And what's the temperature? Temperature on the Earth, average temperature on the Earth is 59 degrees Fahrenheit. That's what makes this such an incredible place to live, because it's actually quite habitable. What's the average temperature on Venus? It's a little hot. 855 degrees is the average temperature on the surface of Venus. Now, you know, you might say, oh, it's hotter on Venus because it's closer to the sun. But let's go even closer to the sun. Let's go to Mercury. What do you think the average? Mercury is much closer to the sun than Venus. What do you think the average temperature on Venus is? Venus's temperature is 333 degrees. So essentially, you've got the Earth at 59, you've got Venus at 833, and then you've got Venus or Mercury even closer at 333 degrees. And the reason for that is because there's a very, very thick heat-trapping atmosphere on Venus that really raises the temperature of that planet. So let's look again let's go back to the relationship between the sun and the Earth. I think we all understand that the atmosphere bounces some of the radiation back onto the planet. That warms it up and makes it a very nice place to be. But we have made significant changes. We are making significant changes to the atmosphere, whether it be power plants, or you can see clearly we're having quite an impact on that atmosphere. So as you change the atmosphere, and as the atmosphere gets thicker, more and more of the sun's radiation is reflected back to the surface of the Earth. And that leads to more warming, because the more radiation that's trapped here, the warmer it gets. So let's just look at what we're starting to see happen. 10 hottest years on record, 9 of them have occurred in the last 10 years. And the hottest year on record was early 2010, was the warmest combined land and sea surface temperature on record. So we had just a long series of high temperatures, and we're continuing to move. And you can see some real impacts if you travel around the world. This is the Portage Glacier in Alaska. There it is in 1914. There it is, not really a glacier anymore, in 2004. This is a picture postcard from 1906 of a hotel in front of the Rhone Glacier in, I don't know if it was Germany or Switzerland, but That's a picture postcard from 1906. That's the same hotel, same site, taken recently. No glacier anymore in the Alps. This is in Peru. This is the Jacambamba glacier in 1980, and that's the same glacier in 2002. So you're seeing a significant diminishment of glaciers all over the world as the temperature gets warmer. So scientists are trying to drill into the depths in Antarctica and go deeper and deeper to try to unlock what they can find about what was the climate like. Because actually, as you drill into the ice, you can see each of those layers is a year. And as you drill into the ice, you go further and further back in time. And in Antarctica, they've been able to go back 800,000 years. And as they go back 800,000 years, they can do analysis on little air bubbles that are trapped in the frozen ice. And those air bubbles are the atmosphere that existed then. So they can really look at, okay, what was in the atmosphere, what was the makeup of the atmosphere. They can really look at that for the last 800,000 years. And here's what they've found in terms of the concentration of carbon dioxide for the last 800,000 years. And it goes up and down, and you can really track with that up and down. You can see there's changes in the concentration of carbon dioxide. And then they do an analysis of the carbon dioxide to really come to understand how that affects temperature. And they've tracked temperature, which is based on the kinds of oxygen 30, 16, 14, whatever, that's in those little samples. And they can track the temperature. And what you can see is that carbon dioxide and temperature have really closely tracked with each other over the last 800,000 years. And the higher the concentration of carbon dioxide, the higher the temperature, and the lower the colder. And so the question becomes, okay, where are we today with carbon dioxide? And where we are as of 2 years ago in concentration of carbon dioxide was 387 parts per million of carbon dioxide equivalent in the atmosphere. All I can say about that is carbon dioxide has never been that high in the last 800,000 years. But where are we expecting to go? Where do we think we're going to end up with carbon dioxide if we don't make any changes, if we just carry on? And where we're expected to go is at almost 600 parts per million of carbon dioxide in the atmosphere if we just continue to burn fossil fuels like we are today. And you clearly can see that there's been an impact for the last 800,000 years. The higher the carbon dioxide gets, the higher the temperature on the planet gets. So it's a little scary when you think about it in relation to this. What's happening? India, 2003, 122 degrees Fahrenheit. Pakistan, 2006, 126 degrees Fahrenheit. Pakistan, 2010, 129 degrees Fahrenheit. So you're really seeing significant warming take place. And this July, scientists say, is really what this July we just had, is what they say this is exactly what global warming is going to look like from now on. And I think all of us can remember the floods in Pakistan, which they're sort of continuing to deal with. A fifth of their land was underwater in July and August and part of September. You can see why. This is the Indus River just flowing phenomenally. 17 million acres of Pakistan's very fertile farmland was underwater, and obviously that had a real impact on families and trying to carry on and do their business and just deal with it. Landslides in China caused by very freak rainstorms this July, killed thousands of people, and just kind of swept through some of the towns. And then Moscow, July 2010, 100 degrees Fahrenheit. It's normally 70 degrees in July in Moscow. 100 degrees Fahrenheit. And add to that, guess what? It got hot and dry, and that led to huge forest fires, and that contributed to a phenomenal problem in Russia, and particularly in Moscow, with air quality. So that people were, it was incredibly hot and it was incredibly hard to breathe. And there you are in downtown Moscow. Want to go on a boat tour? I don't think so. But that's really what they were dealing with. And it was really, it had never been that hot before. As far as I knew, in the last 1,000 years, it had never been that hot in Moscow in July, 100 degrees Fahrenheit. And basically, the Intergovernmental Panel on Climate Change says that this is exactly the kind of events we expect as the climate changes, and we're going to see more intense and extreme heat events because of global warming. We've had some cases in this country too, 113 degrees in Los Angeles this September, Snowmageddon in Washington, D.C. This last winter. It snowed several feet and completely shut the city down and really left people in D.C. to just kind of deal with it and try to get by. And I sort of like this sign. You know, people sort of, there were commentators who were really mocking this sign because, you know, here it is, stop global warming, and it's covered with snow, right? Well, the point is, it's really, the issue is not so much global warming as it is climate change. And the fact is, under climate change, one would expect these kinds of really bizarre snowstorms. And it's all related to global warming because as the globe warms up, it puts more moisture into the atmosphere, and that then leads to things like where it gets cold and snows, and other places it rains, like in Wisconsin this last September, just 2 months ago, a month and a half ago. Really record floods in Wisconsin. So it snows in D.C., it rains in Wisconsin. Incredible rainstorms in Cedar Rapids, Iowa in 2008. And Georgia in 2009 put this amusement park completely underwater. And it was pretty amazing. Had an incredible rainstorm this May in Nashville. Put the Opryland Hotel underwater. And basically downtown Nashville was just completely underwater. 13 inches of rain in 2 days, which is twice as much as it had ever rained based on anybody's records in Nashville. So you can see from just insurance companies that something's going on, because this is a record of insured losses over a period of time starting in 1980 and going to 2004, and you see this incredible increase as we move further down the way. And it's pretty amazing, not surprisingly, when the weather's weird, it's not at all unusual for it to disturb the electric grid. We're certainly aware of that in our area, and it's true all over the country. And this is where the weather has disturbed the electric grids, and by the time you get to 2008, it's really causing quite a bit of disturbance. But it's not just in this country. This is a big river, was a big river in Australia. They are having a phenomenal drought in Australia, an 8 or 10 year drought. And the river used to go from bank to bank, and today you can you jump over it just in one step. And just south of us in Mexico, having the worst drought in 6 decades. And in Argentina, worst drought since 1961. And in China, in addition to all their rainstorms and landslides, they're having a huge shortage of water, 16 million people and 11 million livestock dealing with drinking water shortages. And it's been pretty raking. So it's really a worldwide kind of a situation. So let's look at who emits CO2. So the biggest emitter now of carbon dioxide and carbon dioxide equivalents is China, followed very closely by the United States, then the European Union. Clearly, China needs to be a player with the United States in dealing with this problem. But let's just look at carbon dioxide emissions per person, because that really paints a very different picture. There you can see the China, Africa, and India, and there you can see the European Union, Japan, and Russia. And then the CO2 emissions per person in the United States are, we lead the world. We're at 20.1 tons per person, and China's at 4 tons per person, and they are actually below the world average. So it's very, it's very interesting kind of looking at how do you deal with this equitably. Now, let's just look at gasoline consumption per day. That's each of those little bars is a gasoline consumed in various countries in a single day. And this is the gasoline consumed in one country, ours, United States of America. In one day, we consume more than all those countries put together around the globe. And where do we get our oil? Well, we get our oil both from American supplies, particularly Alaska, more oil from foreign sources, and then a small amount of oil from new offshore drilling like in the Gulf of Mexico, where I think all of us are very painfully aware of the horrendous problem we had with the Gulf oil spill. Over 4 million gallons every day spilling into the Gulf, total of 180 million gallons of oil in the Gulf of Mexico. And we saw some really sad impacts on wildlife and other resources because of that. So clearly we're seeing some real impacts. So let's go for a minute to the North Pole and Greenland. Let's look at what's going on there. We saw birds getting killed by oil spills. We see polar bears are now on the threatened and endangered species list, polar bears in the United States, because they're having more and more trouble living and surviving in a very, very rapidly changing environment that's nowhere near as frozen as it used to be. And you can look at these pictures and pretty clearly see that, yeah, it would be harder and harder to live as a polar bear. And scientists are spending a lot of time studying what's going on up there to try to really understand the changes. And there have been some really remarkable changes. This is the Arctic ice cap in 1980. You can see Greenland over to the left, and then the Arctic ice cap, which gets bigger and smaller winter and summer. But this is the Arctic ice cap in 1980. This is the Arctic ice cap in 2007. Let's just look at that again. This is the Arctic ice cap in 1980, and this is the Arctic ice cap in 2007. So dramatic shrinkage. This is at the same time of the year, dramatic shrinkage between 1980 and 2007. But the thing that's so important to understand about the shrinkage of the ice is that the best reflector of the sun's heat and energy is in fact the ice in the Arctic. It bounces it right off and sends it back into outer space. But as the ice melts and more of the sun's energy is directly absorbed by the ocean, what happens? The ocean gets hotter and hotter, and you see things melt faster and faster. It's a classic, the faster we go, the faster we go. Look at the situation with Greenland. That's the amount of ice. The red is the amount of ice that melted in 1992. That's the red is the amount of ice that melted in 2002, and that's 2005. You're seeing it in the summer. This is in the summer, so it freezes again in the winter, but you're seeing larger and larger parts of Greenland and the glaciers on Greenland basically essentially dissolving. Not surprisingly, the changes in temperature are having quite an impact on the permafrost, the tundra areas that are frozen but aren't just totally ice. And right now, we've got about 730 gigatons of carbon dioxide and a carbon dioxide equivalent in the atmosphere. And as the permafrost melts, and there's a lot of organic matter in the permafrost that's currently frozen, and as it melts, that then produces more carbon dioxide. It's expected that the melting permafrost will double the carbon dioxide in the atmosphere. You can go to lakes in Alaska today and just watch the bubbling of the lake, and what that is methane that's coming from the bottom, and as it thaws, all that gas is released. So let me just show you a very interesting situation. So what that is methane coming out from the ice, and as soon as you punch a hole, the methane that's from the thawing underneath just comes out. Methane is flammable, and it burns. So it's kind of amazing what's going on. And obviously, all of that's leading to the melting of glaciers, the melting of ice and snow, contributing to sea level rise. And we're already seeing some impacts from sea level rise and a rise in wave height in Oregon. You see significant erosion taking place on the coast. And it's pretty remarkable because basically, the scientists have looked at it. Dr. Paul Comer, who's an OSU professor emeritus, says that in 1975, the average wave height was 3 meters, and he says now the average wave height is 4 meters, and that might not seem like much, a 1 meter rise in average wave height, but Dr. Comer says that a 1 meter rise in wave height can push water approximately 50 meters further inland, so that any rise in wave height is much more significant than it may initially sound. And so we're seeing that today on the Oregon coast. Now, I think we should be aware that a whole lot of the population around the world lives fairly close to the ocean. And sea level rise is going to have a rather dramatic impact. You can see in this chart a 1 meter rise in sea level displaces about 100 million people. Take that further out, 6 meter rise displaces 400 million people. Let me just give you one example. This is a country in the South Pacific, or the Indian Ocean. It's called Maldives. And it's a pretty developed country, but its maximum elevation is 8 feet above sea level. And they're increasingly concerned because the ocean is more and more as the waves get higher, more and more really pounding them. And this is the Maldives cabinet. And they signed essentially a Kyoto Treaty-like document underwater, urging people all over the planet to work together at Kyoto. And they signed that a year before Copenhagen, I guess. So urging people to work together to solve it, because they didn't really think they had too much of a future if we let it rise and continue to rise. So basically, scientists say the maps of the world are going to have to be redrawn if we don't do something about global warming. So this is a picture of Mount Hood taken in 1902 of the White River Glacier. And that's same picture of the White River Glacier in 2001. So there it is in 1902, there it is in 2001. White River Glacier has shrunk 61%, and that's the biggest shrinkage of any glacier on Mount Hood. But all the glaciers on Mount Hood have shrunk, and you can see how much on this chart. This is a scientist at Oregon State University. Her name is Dr. Ann Nolan, and she basically has spent time really looking at what's going on with the situation with Mount Hood. And as she looks at it in the glaciers, and as she looks at it, she says there's really been a significant shrinkage, and you can see the shrinkage of the glacier and the red area around each glacier. And as currently, water coming from the glaciers basically supplies the Hood River, and the Hood River provides water for irrigation of new fruit trees and existing fruit trees in the Hood River Valley, about 16,000 acres of fruits and berries that are all dependent on water coming from Mount Hood. But so that's one concern, is that threatens the water that's coming from Mount Hood. But the other concern is that there's something else going on. And that is, as the glacier shrinks, it starts to expose what's underneath the glacier. And what's underneath the glacier is a whole lot of what's called unconsolidated debris, which is basically rocks that the glacier rides on. And then when it rains at 11,000 feet instead of snowing at 11,000 feet, lo and behold, down the mountain comes the unconsolidated debris that used to be under the glacier, but is now just exposed. The rain, this was in 2006, and it's exactly what happened. You just had a huge amount of unconsolidated debris come down the mountain. This is the White River drainage right below the White River Glacier, and you can see that something has really sculpted that river drainage. And it's not just water. What it was all the unconsolidated debris that just completely, dug a hole in the river basin. And you can see, as you go down the river basin, you can see Oregon Highway 35, which rings Mount Hood. This is the bridge over the White River for Oregon Highway 35, covered with unconsolidated debris that moved down the river basin and just got trapped there. So obviously this highway was closed for a while. And in addition, all the water that was carrying the unconsolidated debris eroded out the highway as well, so that you had damage on the bridge, you had damage on the highway. But in addition, there's a railroad that runs around Mount Hood. And you're looking at it, this is the Mount Hood Railroad, and that's the White River. It's the bridge over the White River. And so you can see the White River just coming right up over the tracks. And if you go upstream a little bit from this bridge, this is where the White River clearly eroded the bank and made it impassable. So you could not take a train on that track because you'd end up in the drink real quick. I'm happy to say that the Hood River Railroad has repaired Took them about 2 years, but they have repaired it and they're running again. But clearly, there's a major geologic change taking place because of climate change, because of raining at 11,000 feet instead of snowing. And this is the new delta that's forming for the Hood River flowing into the Columbia River. The Columbia River is right at the bottom of the picture, running left to right, and Hood River is flowing in, and you can see all this debris being carried by the Hood River. So major changes taking place. I think all of us understand that basically the way the planet works is it tries to move temperatures from the warmer parts to the cooler parts. And with global warming, scientists say you'll have a 1 degree increase at the equator, and that equals a 12-degree increase at the poles. So a 1 degree increase at the equator equals a 12-degree increase at the poles, and nobody can tell you what that's going to do to ocean currents and wind patterns, because nobody knows what those kind of temperature changes make. One of the best examples of having us be impacted by that change is something called the ocean dead zone off the coast of Oregon. And the dead zone was really discovered, the most recent time it existed was 2006, but it's happened on a fairly regular basis. They've started to really figure out that it's going on. And Jane Lubchenco, who was an oceanographer at OSU and is now the head of the National Oceanic and Atmospheric Administration, spent a lot of time studying the dead zones with her colleagues at OSU. And it's pretty amazing because they took some video of normal ocean conditions. This is what the ocean at about 60 meters off the coast of Newport looks like when things are healthy. And then this is what it looked like when the dead zone struck. And what you're looking at there is a whole lot of dead crab and some dead fish who could not figure out where to go to stay in the high oxygen water. A dead zone is basically an area where the oxygen has been depleted from the water, and as it moves, unless you can swim away, and crabs don't do that very well, you basically asphyxiate and they just die on the bottom. Another creature, a marine creature that's had some trouble lately is salmon. These are salmon in the Klamath River in 2002 when there wasn't enough water and it got too warm, and about 75,000 salmon died that year in the Klamath River. But what I get really concerned about is that we're seeing some real changes that are affecting a much bigger river system, the Columbia River. Scientists now say that the average temperature of water in the Columbia River in August and September is 68 to 71 degrees. 70 degrees is stressful to salmon. 75 degrees is deadly to salmon. So it creates a real challenge for us looking at the future of salmon in the Columbia River. And this is what scientists project getting out to 2040. The red areas are the parts of the Columbia Basin that are too warm for salmon. And what you're looking at is the entire Yakima River Basin in eastern Washington, the entire Snake River Basin in Idaho, and then between Oregon and Washington and Idaho, and pieces of the Willamette and the Rogue Basin by 2040, too hot for salmon. So there's some real survival questions. Another issue is with the western pine beetle. You're seeing a real increase in the western pine beetle. British Columbia says that 3 years ago, 40% of their pine forests were dead, and they say by 2015, 78% of their pine forests will be dead because of the western pine beetle. Now you might say, well, what does the western pine beetle have to do with climate? Well, the reality is that it used to be that most western pine beetles froze to death every winter because it was colder in the winter. And now, because it's not as cold as it used to be, more of the pine beetles survive year to year and can extend their damage further and further. Seeing similar problems in Colorado with huge destruction of forests because of pine beetle, and you have the same thing here in Oregon. Another area where we've seen some really surprising problems is with oyster production. Go to Washington, go to Willapa Bay, and it's really the epicenter of oyster production on the entire West Coast. It's a huge multi-million-dollar industry. And the way it works is that oysters spawn, and the larvae swim free in the water, and then they attach to shells, and you can see them attached to shells here. And that oyster seed, once it's attached to a shell, is called a set. Most oysters failed to reproduce in the wild in Willapa Bay in 2005, 2006, 2007, 2008, and 2009. Oh, I mean, you know, a year, it's not unusual to have 1 year of problem, but it's very unusual to have 1, 2, 3, 4, 5 years of problems. So they're trying to figure this out, what's going on. And what's interesting is that 80% of the oysters in the hatchery, the larvae in the hatchery, died as well. And that was true at Oregon's Whiskey Creek Shellfish Hatchery. You had a huge die-off. Normally they don't die anywhere near that much. So they couldn't reproduce in the wild. They couldn't reproduce in the hatchery. So people scratch their head. And one possible explanation relates to the amount of carbon that we're putting into the atmosphere. 6.3 billion metric tons of carbon from energy production every year. Half of that stays in the atmosphere. The other half is sequestered by plants, trees, and the ocean. When the ocean absorbs carbon, what does it do? Carbon becomes carbonic acid, and it raises the acidity level of the ocean. And so that's one of the concerns that scientists have really started to express about, is that what's happening? Is that why the oyster larvae aren't able to set, is because of ocean acidification? And they're not sure whether that's what's leading to killing baby oysters, but it certainly seems like a high likelihood. So scientists in Oregon, at the University of Oregon, have done some specific work in some specific regions. And one of those regions is the Klamath River Basin, which is in the upper part of it's Klamath Lake and in Oregon, and the western part of it's in California. And I think we're all familiar with the farming that goes on in the Klamath Basin. And then there's a lot of mountainous terrain in California for the Klamath Basin. And they've developed, the scientists at U of O have developed real analysis of what climate change is likely to do in various basins. And one of them is the Klamath Basin. And here's what they expect. They expect temperature increase by 2075 to increase, between 3.8 and 6.5 degrees. But more importantly, they expect summer temperature increase to be up to almost 12 degrees Fahrenheit, which really would be hot in the Klamath Basin. And they expect snowpack to decrease on the mountains somewhere between 73 and 90% because of that temperature increase. And the temperature increase obviously would have an impact on water supply, because currently snowpack provides sort of a reservoir of water through the summer, and as snowpack declines, it would obviously have a direct impact on water supply. I think we're all painfully aware of what happens in the Klamath Basin when you get a water shortage. We went through it in 2002, and it was not pretty. And it was not pretty for farmers. It was not pretty for fishermen. It was not pretty for tribes. It was not pretty for wildlife. It was not pretty. Essentially, the farmers are threatened because particularly grain and potato crops are, as you have temperature increases, more and more likely to fail. Fish obviously are affected by less water and more heat, and more of them die off. And you have things like algae bloom in Klamath Lake, and that killed the suckers in Klamath Lake in 2002, and you can expect that again. So essentially, the changes in climate in the Klamath Basin affect crops, affect wildlife, affect fish, and affect people. All of those are going to be affected, and it's a little when you look down the way. Another place where the scientists really looked closely was the Upper Willamette Basin. And the Upper Willamette Basin, basically Eugene, Springfield, from the Cascades out to the Coast Range. And as they looked at it, the models agreed that the annual average temperature in the Upper Willamette would rise 6 to 8 degrees Fahrenheit by 2080. So, and it was not at all, I mean, we had a 94 degree in May of 2008 in Springfield, so you're already seeing that. And intense weather events in the Upper Willamette, such as flooding, will put developed properties at risk. And if no action is taken to prepare for the likely climate change impacts, damages could amount to millions of dollars, including damages to road, air, and rail transportation. And this was pretty remarkable. They were very concerned that there would be consequences for human health because of degraded air quality, potentially raising the rates of asthma and other respiratory problems. So the report recommends the establishment of cooling centers to reduce health consequences during extreme high heat events, particularly for those most vulnerable, including the elderly and the infirm. And the interesting thing was that they really saw a significant change in growing conditions because of the change in temperatures, and that would have fostered a shift in crops and orchards and vineyards. And one adaptation that they talked about, and it's not just for the Willamette Valley, but it's for Oregon as a whole, is really a switch from growing Pinot Noir, which is really the signature grape for this state, to a much less delicate grape like the Shiraz. And I personally love Pinot and would hate to see us lose production of Pinot Noir, but that appears to be what we might be headed toward. Scientists have also done a look at what does it mean for the Rogue Basin, and the study predicts that dry season temperatures will increase by 15 degrees before 2080, summer temperatures, and as a result there'll be far less snowfall than in previous years, and the extended dry season means that snow will begin melting much earlier than in previous years, and that means that more precipitation will fall as rain rather than snow over the next century, and the transition from snow to rain and the faster, earlier snow melt will combine to create flashier spring and winter floods, posing a major flood hazard in the Rogue Basin. At the same time, decreased snowfall and increased temperatures mean that in spite of flashier spring floods, Rogue Basin streams are likely to be much drier during the extended summer months. Now, drier streams in the summer means dead fish. Dry streams will in turn increase threats posed by bacteria and disease from the water, which will reduce the number of fish that are able to live and live successfully in Rogue River streams. Scientists also say there's a real increased risk of wildfires with greater heat and more drying. And they say there'll be some likely changes in native vegetation. Higher elevation vegetation is really projected to be at risk. Currently, if you look at the lower picture, currently the dominant species in the Rogue Basin is conifers, and it's expected that the conifers that are the dominant species now, that's what you cut for timber, are the dominant species is going to be replaced by mixed pines, hardwoods, and madrone. Those will become the dominant species in the Rogue Basin. So real changes both to what we're used to and real changes to economic issues in a number of places. So that gives you a sense of kind of the changes that scientists are really starting to talk about in terms of Oregon and the changes that we will see from climate change. And clearly, those kind of changes are not real pleasant, and it's certainly something we should, I think, work hard to prevent. And a lot of countries around the world have ratified a climate treaty called the Kyoto Protocol that's been ratified to basically start to control greenhouse gases. But Kyoto was not ratified by the United States, and it was not ratified by Australia, which were the two biggest industrialized countries to not ratify Kyoto. But then Australia elected a new prime minister a couple of years ago, and Australia ratified Kyoto. So that left the United States as the only country that had not ratified Kyoto. We then elected a new president. He basically has said that he really wants to see this country take action on climate change. I think all of us are a little frustrated right now that that's not happening, but the reality is that it takes 60 votes in the United States Senate to get something done, and there are not 60 votes in the United States Senate right now to enact significant climate change legislation. So there is real efforts underway by the Obama administration through the Environmental Protection Agency to regulate greenhouse gases as a real pollutant under the Clean Air Act. And the Supreme Court of the United States has said that the EPA can and should regulate greenhouse gases as a pollutant. So that's what you're going to be seeing in the next couple of, actually probably the next 6 months. You're going to see more and more action related to that because Kyoto and Copenhagen did not take significant action to move forward. There's a lot of support in a lot of cities around the country, and a whole bunch of them, 16 or 17 of them here, to see real action taken on climate change. 884 cities. A whole lot of CEOs of big companies say we've got to deal with climate change. We've got to take the actions to reduce carbons. We need a cap on CO2 now. You also see significant support in large sections of the religious community. This is a quote from our current Pope saying, you know, God put man in the place to take care of this planet, and we got to take care of it. And the Pope has now installed solar panels on the Vatican to provide for the energy needs of the Vatican, and instead of so they're doing it so it won't be a real source of global warming. And you have real changes even in some of the more conservative religious sects in this country. Southern Baptists had been very doubtful about climate change. They'd been particularly doubtful about Al Gore, but they really came to a realization that there's some real problems that they really need to deal with, and they have now adopted a statement that says the time for timidity regarding God's creation is no more. So they're now really engaged as well. So you've got a lot of people, whether it be political leaders around the world, whether it be business leaders, whether it be religious leaders, whether it be local government and city government people, basically saying we need to do things about climate change. And Al Gore issued a challenge not too long ago to deal with climate change. And he said, let's have 100% renewable and clean electricity with 10 years. And you can do that through energy efficiency and renewable energy and a unified national smart grid, which is a way to transmit power. And the result of that is 100% of clean electricity and clean plug-in cars. So that's really what the goal is. So question would be, well, why Repower America? Why do something that Al Gore suggested? And it relates obviously to climate. It also relates to a really tough time we're having with our economy. And it relates to national security and how much we are dependent on some very unstable parts of the world right now. So I love this quote personally. Al Gore said a couple of years ago, we're borrowing money from China to buy oil from the Persian Gulf to burn it in ways that destroy the planet. Every bit of that's got to change. And so the question is, okay, well, how do we do it? And this is what you're going to be talking with people about, is what are the kinds of things we can do? Well, let's start with energy efficiency. Obviously, having more efficient homes, getting upgrades can really save money, can create jobs, and it can save energy. This is a typical older American house, and the red is the places where it's losing a lot of energy. You can see that there are places and things you can insulate the attic and stop the energy flow out of that house. Better light bulb. I live in West Salem. Salem Electric just sent me a huge box of compact fluorescent. Yeah, Lori too. Oh, big box of compact fluorescent lamps, and we'd already bought them to screw them in. But it's basically it's remarkable how much energy you can save by changing the light bulbs you use, and still have plenty of light to read by and enjoy yourself. So it's real clear that energy efficiency can really help us move in a very good direction, save money on energy bills, and just stop wasting power in standby mode, which is something that is pretty remarkable how much power gets used in standby mode on computers. California has done an energy efficiency program, and their energy efficiency program has avoided the need to build 24 power plants equal to the energy required to power 3.8 million homes. And they've done that not by building new power plants. They've obviously done that through energy efficiency.
Old places use less energy. We can save money and boost the economy. It's not about turning down the thermostat and putting on sweaters. It's about repowering America. One of the fastest ways to cut our dependence on old, dirty fuels that are killing our planet. It's a great idea, unless you've got a problem with creating jobs. Repower America. It's time to get real.
So that's an ad. There's been a series of ads that really talk about things we can do to really move in the right direction. So the next part of Repowering America is obviously renewable energy, and we're a big player in that in this state. Wind turbines can be a big contributor both in the Columbia Gorge and in Texas and in the Midwest. 10% of our electricity can come from renewable sources by 2012. Obviously, we're already moving in that direction. This is the wind farms on the Columbia Gorge and Fossil. These are some people who work on the wind farms. These are union IBEW members that work on the wind towers in Central Oregon. And Obviously, there's another thing that can be done, and that relates to solar development and really concentrated solar development. It's real clear that as you really start to find ways to harness the sun, you can capture phenomenal amounts of energy in very small areas that can then be used very effectively. Best example for us is that Solar World, a German company, located a large manufacturing plant in Hillsboro, Oregon. Has put about 1,000 people to work producing solar panels, and it's been a great assistance. And there are a whole bunch of other companies that are working around Solar World, so it's a real economic opportunity. There are training programs at our community colleges to help people really become a part of the workforce, and those are all companies that are working here in Oregon related to developing renewable energy. So it's a real economic as well as important environmental opportunity. I just would emphasize this is just an estimate of some of the new jobs that can be created through renewable energy development, solar and wind and green building, smart grid, etc. You can really, projecting about 62,000 new jobs in Oregon and Washington. So the question is really, can we do this? Can we mobilize? And I'm reminded that we sure did. We can do it in World War II, and I'm reminded of Martin Luther King mobilizing for civil rights, and I'm reminded of our ability to put a man on the moon. John F. Kennedy said we were going to do that in 1960, and sure enough, in 1969, we did that. It's clear that it's a challenge, but it's something that we really have a remarkable ability to do. And I personally believe that we really can do it, and we really must do it because we're all citizens of this amazing planet. And my grandson really says, I want to live here too. So I hope we can all work together, and I'm just really excited about what you're embarking on to really provide real information to people to help reduce their greenhouse gas impact and in fact make their lives better. That's what I think is so exciting about what you're doing. Is it's not just you should do this. It's stuff that can be done that actually makes people's lives better in terms of lower cost, more energy efficient. And it's really nice to sit around with your kids and sit around the fireplace and be warm and not have your electric heater on. So thank you all for what you're doing, and carry on. So I don't know if we want to...
Sure, take some questions. That's
Sure,
what,
okay,
how much
questions?
time you got?
I don't know. Yeah, I hate to think how long that takes.
Sir, are there any questions for Joe?
That's not
I actually have a question. Is somebody else?
Yes.
Oh, go ahead. Great.
Oh, is there like an average global temperature tipping point at which you'll get runaway global warming?
Well, that is the question that scientists just bite their fingers about. There are some scientists now who say we've gone beyond the point. There are other scientists who say, no, we can stop it. And there are other scientists who say, we're not close. So it's really, I got to tell you, nobody, I'm certainly not a scientist to be smart enough to tell you, but the scientists are really divided. They just don't know what, do we get to a point where it's just run away? And they just don't know. There's some people who believe we're already past that point.
I've heard some comments that even if you could throw a magic switch and stop all fossil fuel burning, that since there's a lag between temperature increase, and when it stops, it'll continue to rise to a certain level.
Right.
Have they figured that out, or can they?
Yeah, scientists do agree on that.
Yeah.
That even if they certainly agree that even if you stopped all fossil fuel use, which is not going to happen, but even if you did that, there would be a lag because there's so much greenhouse gas already in the atmosphere that will have an impact, even if you're not adding to it, that will have an impact.
Well, too, if they do, if just in that sort of an idealized case.
Well, what do they say? I think the scientists say if we could get carbon and carbon equivalent down to 380 parts per million, which is a little bit below where we are today. If we could do that, you'll probably see about a 2 degrees Celsius increase. I think that's right. It's about 2 degrees Celsius, which is a lot. But that's sort of what they say. Well, that's sort of, they're basically saying that's pretty well, something like that is pretty well built in. So it's going to get warmer, clearly. But and scientists don't. I have to tell you, scientists don't really know whether it's going to become, uninhabitable. They just don't really know. It's just, I guess my view of it is that it's real clear that yes, we can do a heck of a good job making this planet unpleasant and unlivable, and we don't know what the magic point is, but I'm quite clear that if we keep doing what we're doing now, it's going to mess the planet up. And it's real clear that we got to try to reduce things, because that'll be better than just letting it go the way it is now. But nobody can really tell you precisely.
What's the chance that Oregon legislature will do something about climate change?
Well, I wish I could tell you. I don't know. I can tell you that our current governor worked very closely with governors in other states in the Western Climate Initiative. And the Western Climate Initiative was initially Washington, Oregon, California. And then it grew to include Arizona, New Mexico, and several provinces in Canada. And a number of states, the California legislature enacted legislation, which is now subject to a ballot measure. The Assembly, they enacted major legislation that now there's a ballot measure, I think it's ballot measure 23 in California, to repeal it, which is funded entirely by the oil companies. But we'll see. We'll see in a month what the people of California do. So California enacted legislation. There was legislation proposed by the governor for the last session of the Oregon legislature, and they did not enact it, and neither did the Washington legislature. And part of what's going on is there are some there are just some very, very clear interests that are not served well by dealing with climate change, particularly the fossil fuel industry, and that's oil, gas, natural gas, those kinds of industries don't do well. I mean, their future doesn't look very pretty if you actually deal with climate change. So it was very interesting last session because they don't just real publicly say anything. They just work, legislator to legislator, and sort of sow doubt. And and granted, there's lots of questions. Okay, nobody's going to say they have every answer, but they just sow doubt, and then they just say, "Don't do anything," and that's exactly what happened. The governor proposed, and the legislature disposed, and that's what they did. They just didn't do anything, which is the easiest thing for the legislature to do, is nothing. And that's what they did. And that's exactly what the oil companies wanted them to do. Nothing. So it's a huge challenge. It's not easy, but I do believe that what's happening this next session is not focused on climate change. It's focused on energy efficiency. And there's a whole lot of efforts, there's a whole lot of good things we can do that reduce our greenhouse gas production, that also save people money and also reduce our energy needs, which you're going to see a lot of legislation focused on that, and they're not going to use the word greenhouse gas. They're going to talk about energy efficiency and saving money. So I think you're going to see some major progress in the next session on energy efficiency, but not in the name of greenhouse gas. I'll just say I'll take it however we get it. I don't know. Yes.
Kind of following along that idea of the language that's used and how
Yes.
issues are framed. That's sort of in the political realm, but I puzzle over on the grassroots level when you're talking neighbor to neighbor. One of your slides, the snowstorm with the Stop Global Warming slide, brought it to mind. The use of language is so important. And is it global warming? Is it climate change?
Right.
Is it climate instability? Do you have, I know there's been some research done, I think about 3 years ago there was some research that said that people responded, even though climate change was a broader phrase, people responded better to global warming, and so there was some shift kind of in the national thinking. Perhaps you were more privy to it than I was, but about what kind of language to use. So I'm wondering what your thoughts are on how your layperson on the street is responding to those different phrases.
Well, I think it's interesting because climate change doesn't sound bad. Climate change, well, gee, it's kind of too rainy in Oregon. Climate change might be good, right? I mean, it doesn't sound bad. Right. Global warming sounds bad. But Snowmageddon in D.C. makes it very difficult to talk about global warming. The reality is that because the globe is warming, more moisture is put into the atmosphere. Sometimes it comes down as snow, sometimes it comes down as rain. That's the reality. But I know that just because I've kind of spent a lot of time sort of figuring it out. But I don't know what I think global warming is just a tough one, I think, just because it's, yeah.
You get a sense that the corporate leaders, who in theory are smart, believe in climate change but don't act on it because of corporate interests? Or do you think they believe it?
I don't know. I mean, I think it varies. I mean, I think we really failed in terms of really making it clear the crisis we have. And as long as people can get away with just being concerned about their bottom line next week or next month, that's what they're going to do. And until they're, I think about sort of other times in this country. There was a major change in this country as it related to civil rights, for example. And it just became very clear that people needed to deal with the issue. They couldn't just kind of go on making money, right? I mean, they just had to deal with it. And I think I don't know why, but I think that there are those who don't want us to do anything, and they're very good at, kind of constantly. Well, I mean, I remember, right-wing talk radio just having a heyday with Snowmageddon in D.C. They had a heyday with it, because they're all back there, right? And they had a heyday. Well, it's very, those kind of things are very frustrating. And I don't, I think people who, I've never run a company, so I don't know, but I think when you're running a company, your first priority has to be your company. And as and as long as, we keep this political sort of debate going, like, well, it's not global warming, there's nothing happening, there's no climate change. As long as that's going on, people don't feel like they need to deal with it for the health of their company.
Have you heard anything about COP16? Because I haven't heard anything lately about it, and I'm wondering if there's any chance of getting a global agreement that would include China and the United States and be fair to the small island nations.
COP16 was Copenhagen. Was that Copenhagen?
No, COP16 is the next one.
Next one, which is in Cancun.
Mexico,
right.
Somewhere, yeah.
All I've heard about it is that nobody's trying to get a global agreement. That's what I've heard about it. Is that I've heard it described as not trying to get a global agreement. Everyone from around the world is getting together, but my understanding is the United Nations is not trying to get a Kyoto-type settlement. And, well, I think what really people have realized is that there are some fairly fundamental issues that have to be got to come to grips with. Part of the issue is the developing world sort of says, well, excuse me, get back. You look at what you've done, you, the United States, you, whoever, look what you've done, and now you're saying we can't do it? Hello? I mean, and I don't blame them. I mean, I think you got a real challenge there to figure out equity, right? And then you got places like China, and I got to tell you, China is going to go way past. I mean, they're a huge offender right now. Offender's the wrong word, but huge with their coal plants because they had to develop all this power for their economy. But they are the largest wind producer in the world today. They are about to surpass Germany with solar production. And they've recognized, because their people have to breathe the air, they've recognized they got a problem. And the thing that I sort of have learned about China is that, yeah, they're going to just absolutely continue their policy, as long as it serves them, but they know they have a problem, and they know their people have a problem in terms of their air. So they've really got to deal with it. So they're really working on, I think you're going to see them in 5 years go way past this country and Europe in terms of clean production. Oh, gazillions. They sort of look at it, and And it's like China, yeah, China has been resistant to, an additional treaty. But boy, I tell you, the leaders in China know that they got a problem that they got to deal with. They're just trying to figure out how do we keep our economy okay and deal with this. And the thing that's interesting about China is once they figure it out, they'll do it. Because they're not a democracy. They don't have 60 votes in the United States Senate. They will do it. So, I think it'll be very interesting. I wouldn't be a bit surprised. I mean, I guess I'd be a little bit surprised, but I wouldn't be a bit surprised to see them be the global climate leader in about 5 or 7 years. So
do you have a vision of how we could crack this nut and really move forward in a timely manner?
do I have a vision? Well, yeah, yes, and I think I think the work that you're taking on to do is exactly the kind of work that's going to really help us move toward implementing that, and it's all the things that we can do as communities, as a state working with other states. There's a whole series of things we can do to reduce our greenhouse gas production. Now, I think all of us understand that you're not going to really solve the problem completely until you have both serious efforts by individuals and real action by the government. I think it's going to take both. But it's real clear to me that if you have more and more people taking action as individuals, which is what I see all of you are working on, it's real clear that the more people that you engage and get taking action, they start to talk to their friends and say, well, I think we should do stuff like this. It saves us money. I'm more comfortable, and I feel better about the environment. So I think that's part of it, is just to really get more and more people taking that kind of action and talking with their neighbors. And I hope that we get to a point where shifts take place very quickly. But it's sort of like, well, I remember the war in Vietnam. The attitude about the war in this country, for a long time, it was just a bunch of crazy wacko students. I was one of them, fighting the war, right? But at a certain point, just a large majority of the population just went, yeah, no, this doesn't really make sense. And things turned very quickly then. We can talk about Richard Nixon a little bit, but we won't. But things did turn. And I think the same kind of thing can happen with climate. I got to believe that it can. And it really starts with each of us talking with other people and getting them to do things that are really good, sensible, that they like. They say, oh, this makes sense. And I think that sort of gives you more and more of a core. So, because, I don't see it happening politically right now. The opposite might happen right now. I don't know, but I don't see it politically right now.
I think we're going to take one more question, if that's all right with Mr. Bradbury.
Sure, of course, sure, absolutely.
After that, we can cover that, because we're running out of time.
I just wanted to comment that the discussion that involved China and then moved into how to implement what we all want to do needs to fully take into consideration what the Chinese obviously understand. A huge leg of their present and future economy is their transition. And that's, I think, a key item for us to share with our friends and neighbors, that we have to rebuild. Let's rebuild it, right?
Right.
And it can be huge, it can make computers look like kid stuff.
Right, and I think that's a very good point, that actually the Chinese, I mean, they see it, they see the environmental stuff, but more they see, I mean, in addition, they see a significant economic opportunity producing wind turbines, producing wind energy, producing solar panels. I mean, it's not just sort of, oh, let's do right. They see it as a real opportunity. A very good point. So,
we've had environmental energy into getting tax credits and all kinds of programs. We do I hear some, I read some folks saying we went too far, it's costing the government, Oregon government, too much money. What is your prediction as to how we retain some of those credits?
well, I think the real, the biggest tax credit in Oregon is the business energy tax credit. Okay, and I would agree with critics that, you know, already profitable, successful wind farms on the Columbia Gorge don't need tax credits to encourage them to build their wind farms. Okay, so why are you okay, so that's the kind of thing that you should you can get rid of. But I think the real important area would be to keep the tax credits in the energy efficiency area, because that's really the place that we can make significant improvements that are a little harder to find the cost effectiveness in the first. I mean, it's real hard to make money doing that. So that's a good place for tax credits to stay, is in energy efficiency. And, you know, I'm sure in some other areas too, but it's going to be a real challenge next session because they have such a big deficit. It's going to be a real challenge. We're going to have some smart people focused on what really matters to keep it. So, thank you all so much. Woo! Great fun.